How's everybody doing today? On this fine Friday. Nothing like trapping on a Friday, am I right? Friday vibes, yep, exactly. It's been a pretty good week. We've ran these workshops basically every day. We've had some great participation from the community. And actually, we already have a couple people that have done their homework before the workshop has even started. There's already a couple people that have done this workshop actually. Someone's saying, was wondering to get a role for participating in the workshops. Is it mandatory to on-chain Discord confirmation? Or is it possible to qualify for it to create content for the workshop? That's a good question. I think I can talk to the team about that. But the main plan was to get this special role. You would actually create a trap. Specifically, this last workshop is the kind of like final one to kind of do proof of trap by pushing your name on chain with this workshop. That will act as like the verification that you actually created a trap that performed this action. So that would be the main way to get this role. That's why this workshop is the most important. Bringing everything together from the past 3 workshops plus past 2 workshops plus the intro workshop. So this is the big one to kind of prove your might. Yeah, proof of trap. Let's go. Yep.
Okay, let's. Okay, awesome. Okay, everyone can see my screen?
Sure.
Alright, awesome. Well, thanks for showing up today, everyone. This is the most important workshop out of all of them so far, and our grand finale here. I sent the link in the chat if you scroll up a little ways. Today we're going to run through workshop 3 here in our Drosera Workshops repository. Now today we're going to do something that we haven't done so far. Yesterday we successfully updated our trap, but all we changed was some configuration fields in our Drosera.toml file. But today we're going to update our trap from the side of actually changing the trap code itself. So let's kick off with that. Let's just go take a look at what we're working with so far. So if you go down into your 3 folder here, inside the source, we have our actual, our trap itself. And if you've been following along, then you'll see that this looks almost identical to the previous traps that we worked with in workshops 1 and 2. Essentially the same thing. We're testing if our response contract here, if it's active, every block, just seeing if it's active. And then, so should respond gets simply a Boolean as input from the output of collect, active or not. And if it isn't active, then we'll return false with no bytes. But if it's true, what is the name thing? So this is the new piece that we're going to add on here. We're going to specify our Discord name here as a constant in our trap contract. And for each collect, it's simply going to return our hard-coded Discord name. And then when we decode, so now it's not only a bool, it also has a string with it as well. And that is our Discord name. So when we return true here, it will encode our name, and this piece of data here, um, for this argument, this is what gets passed to the response function as an argument. Okay, so the first thing we're going to do is we're going to go update our new response function, and that is going to be respond with Discord name. Okay, now make sure you don't just double click highlighting this. You have to get the whole thing, or it will not be correct because this gets hashed. Be carefully, make sure I have exactly it. I'm going to come over here and replace some other response function with our new response function, respond with Discord name, and it takes a string, and of course that is the actual Discord username. Okay, now let's update our response contract. This does not exist on our Workshop 2 response contract. So you can find the Workshop 3 response contract here in the Workshop 3 trap. That is this address, E600E. And also, you need to update the path to point to the Workshop 3 compiled trap code. So I haven't compiled it yet, but that will be going to the out folder here. So all you need to do is just update the path here and change from Workshop 2 to Workshop 3, and it'll be in /out /Trap.sol, and I haven't compiled it, but it will go in here, and that'll be the compiled trap code that actually gets deployed to the seed node. So, and everything else, I think we can leave the same. I still have my same whitelisted operator that we're going to use to actually run the trap. And again, let's see, this trap is already deployed. We're just updating the code behind the trap. Okay, so let's take a look at the next step. We updated our Drosera.toml file with our new function signature and our new response contract address. Finally, we need to update the actual trap with our Discord name. Okay, so let's go back to our trap here. Now we already have a field here to make it easy for you. This is already plugged in here, right? Collect returns the Discord name and then should respond, decodes and pulls it out and evaluates it. So I'm simply going to add my name here, my Discord name, put that in there. So now every time the trap, an operator is running this trap in every block, it's going to run the collect function, and it's going to pull my Discord name from this constant and return it alongside if the response contract is active or not. In the should respond function, when it gets the data from collect, not only is it checking if the response contract is active or not, it's also checking if the length of the name of the Discord name here is 0. So if you don't enter any name here, then this will return false, and it won't call the response contract. So your Discord name, of course, will not be recorded on chain, and you don't get enroll. So put your Discord name here so that the length isn't 0, and then the contract will be active because it is active, and you'll have a name. So then you'll get a return true, and it will pass your name encoded as the argument to the response function. So it will go on chain, and will call this contract, and it will call this function on this contract, and it will pass in your Discord username here, and then your username will be recorded on chain, where then we can grab it in the future and give out roles. So that pretty much covers the setup here. Okay. So yes, we're going to run through some of the same exact steps we've been doing on other workshops. Continue driving home the general trap developer life cycle. So let's pull up our terminal. Okay, now the first thing I'm going to do is, in our instructions, we need to forge build, and this is especially important because I just made a change. It is now different because I added this. So we need to recompile this code, and we have an easy command for doing that, and that is going to be make build workshop 3, and you can see under the hood what commands that actually runs. But I'm going to go ahead and run this, and this is going to compile. Okay, well, maybe I ran through this testing some of this before, so I think I've already done this. But you can see it CD'd into workshop 3 and ran forge build. I think if I do something like add an extra S, I think that will trigger it. Yep, there we go. Compiling one file. Okay, bring it back to my actual username. Okay, great. So we're good. We're all compiled. So now we have the proper compiled trap code to deploy on chain. So let's test everything with a quick Drosera dry run to make sure there's no runtime issues with the trap code. Great. Okay, we got
a
a
question, Jake here.
yeah.
Do you also need to make sure that that TOML is pointed to workshop 3?
Yes, I think I covered that, but
Yep.
yes, I had from yesterday, this was /workshop-2, and I did, a couple minutes ago, I updated this to workshop-3, um, so that it points to into workshop 3 into the compiled. From running forge build, it compiles this trap and it stores it in the out folder. Um, from doing workshop 2 yesterday, it was pointing to the compiled workshop 2 trap. So I just redirected it so it's pointing to this. So when I run Drosera apply, it's actually going to take this compiled trap code and deploy this. So yes, a good question, and that's really a key point. If you didn't change this, then you'll be deploying completely different code, and so you would be expecting like this to happen, and it won't happen because it never got deployed. It deployed an old trap. So definitely something to gotta pay attention to that. Okay, so we ran Drosera dry run, testing our runtime execution, making sure that the trap works for a 1 block cycle. So it ran, did a test run on block 3,920,521. We got a true response back, meaning our response contract is active. And for the first time, now we actually have some response data. Every other workshop we've been running so far, response data was just 0x, which is nothing. And now we actually have some encoded data here, and that is, where is it? That is my Discord username here, and which is this. It's the ABI.encode of my Discord username. Okay, so everything is working. So now let's send this on up to the real world. With a Drosera apply, this is going to update any relevant information in the Husky on-chain trap config, and the trap code is going to get updated to the seed node. Okay, let's run Drosera apply. It's going to run dry run. Again, all good. Then it's going to make a plan. This trap is already deployed, so it's an update. The trap hash is changing because the previous trap hash, this is data from on the on-chain trap config. This is from the workshop 2, the hash of the workshop 2 code, which is the last one I deployed, and I'm updating it. It's this new workshop 3 contract, so the hash is different. We changed our response contract, so now we're pointing at the workshop 3 response contract. We changed our response function. Now we respond with Discord name with a string. And don't worry too much about this one. Okay, so of course, let's deploy. And now we hope that Husky is not running super slow. All right, quick today. Okay, so we have shows our address here again. If it's an already deployed trap, this address will not change. We're still F1, F89, which you can see is still what we have in here from the very first time we deployed this trap in Workshop 1. Okay, so that's great. Now, let's go test. Again, I keep doing this, but I just want to I like to do a before and after. So I'm going to make a call to the response contract um, for this response function. So this is our response contract, and I'm going to that response contract, and I'm going to call isResponder, and I'm going to pass in the address that I used to deploy this trap, the the the, the private key, the address that owns this trap, and see if I've responded. Like the response function has been called, and see if that's happened. Which, if you picked up from so far, you will know it won't be. It's false. I haven't responded because deploying the trap is not enough. It also needs to be being run by at least the minimum configured number of operators, which is currently set to 1. So I need to go spin up my operator. And again, from the previous workshops, we've been working with the same trap the whole time. So my operator is already opted in, and my operator is already registered. I registered my key at the beginning, so that's a one-time step. And then opting into a trap, that's also a one-time step. So I can continue on the trapper side of things, I can continue updating this trap as many times as I want, and all the operators that are opted into it will just get the updates and automatically run them. There's no need to keep opting in or opted in after a new trap updates. Okay, so I'm already opted in and I'm already registered, so I just need to run my operator, and it should pick this up. We wait a little bit after some initial setup, and then we should see it will print out a big blurb to the logs here showing that we submitted our claim, which is when should respond returns true. There we go. Successfully submitted claim. Okay. So now we can go test our call again. So successfully submitted claim, to be clear, that means it went and called this actually on chain. Respond to Discord username. So I should be able to see that I have responded now, and my Discord username is stored on chain. So let's run our cast call again, see if I'm a responder. It was false before, and now it's true. So now my Discord username is stored in our response contract, and I have a new Discord role coming up. So that pretty much covers Workshop 3, I believe. So now you know how to update your trap, the actual trap code, compile it, deploy it, update it, um, and then you can take it from there to build any sort of crazy trap ideas that you have. And that concludes Workshop 3, I think.
Okay, cool. Yeah, so it's really bringing together all the pieces that we've done so far. This is the first time that you'll have actually changed some trap logic. And so for you guys running this, just specifying your current Discord username will be the easiest way to run this thing. And then the team will basically be actually ran the workshop. And so this is really important uh, for us to have run these workshops so that we can kind of temperature check the community a bit and see like how many people can follow along and do these things, how many people can go through the process of just deploying a trap and then changing a really small amount of trap code. Um, this is all kind of leading up to our capture the flag challenges that we will be running. And so we want to make sure that we've got a good set of people that will be ready for running those challenges. Um, and this is a good way for us to make sure, can you get through essentially Trap Academy 101? If you can do this, then you've got a good shot at being able to do um, the the upcoming challenges, which will be important because we'll have a leaderboard for people that participate in the TryTrapMe challenges. So that'll be another place for people to kind of test their might, show us what they can do with traps, and yeah, it's just a really good way to kind of participate with testnet and a good opportunity to be seen as kind of number one trapper of each challenge that we send out. Um, so yeah, I think that that's really the main point of this. Um, if there are any particular questions, I think we can cover them. Uh, yeah, and I can actually even just bring up a diagram as well to kind of further hit this point home with like a visual aid. Yesterday, I brought up a diagram um, showing how different response contracts can be hit and configured. I'll just bring up that same diagram and then make a couple small changes. So let me pull that up. Okay. Okay, so this was a bit of the craziness that we did yesterday. Let me go ahead and remove some of these pieces. Let's just remove this guy. We're gonna only keep one contract. All right. So, uh, for for this specific workshop, um, we had the response contract and response function configured to call this like very specific contract on chain, right? And uh, I don't know what was the name of the function, Jake, out there on that contract?
The response
The
contract.
response function itself that was on that contract.
It's respond with Discord name
Okay. Yeah,
with
so
a string.
respond with Discord name, something like that, right? That's what the response function was on that contract, and then we basically just configured that trap to point to that name. So I would put this name with string in the response function, and then I would specify the address of that response function, which isn't for 2069. It's some other hex, but it's something that already exists in that workshop. You'll see it in the trap logic and follow the same steps that Jake did to go and update his TOML to match this. Happening is we have this kind of like off-chain piece, which is our trap contract, right? And in that trap contract, you had Discord name, and Jake set it to Jake Rumbles, right? And what is kind of happening here is that Drosera operator, because it's opted into this trap, it's running this trap logic that is using this Discord username, and then this Discord username is effectively getting passed from that contract all the way on chain. So it starts kind of from the trap contract. It's being run by that operator. When should respond is true, it passes that name all the way on chain, and then it pushes it and stores it in this contract, right? And so it's being stored in this contract now, and then there's a specific cast call, which is like being able to read from the blockchain, being able to read from this contract. The specified workshop that's called is, um, I believe it's called, and this will pass back a string. So when you call this function, let's just move this guy here. When you call this function with a cast call, this will return true based off of the address that was passed to it. So the address is like the address that you used contract. So whatever account you're using. So if your account that created this, we would call it like owner, owner or creator is 0x 1234, then that, if that's the owner and the creator of the strap contract, the the key, the public key that is associated with the private key you use to deploy this contract, that is what you would want to use for this cast call for the is responder. And this will return true if stored a Discord username on chain. And so there's only been a couple of people already that have done this. But this should be a good way for you to verify that your name got put on chain. And the team obviously will scrape that contract to grab the rest of the names that have been pushed on there. You only need to run this, one time. Your operator only needs to do one submission. Then you can, stop your operator from running. Otherwise, the operator, once it gets out of cooldown, it will continue to try to. It's not triggering on a one-time basis. It's simply whenever it comes out of cooldown, it will just try and send your name on chain and do that response function. Okay. Do we have any questions? Anything in the chat asking about the workshop?
Got a couple in here.
Yeah, we have. What if my operator is stuck on should respond is true and says cooldown is active? Can you explain the cooldown process? So for the cooldown process, the reason that that exists is it's kind of like you being able to set any field that you, or any number you want for your cooldown. Right now we have it set to 33. And a cooldown period is measured in blocks. So what that means is when a should respond is equal to true, and your operator actually makes a transaction on chain, it actually calls the response contract, there'll be a window, a cooldown window of X number of blocks in this workshop. So that would mean if the operator continues to run and you just continue to let it run, after 33 blocks have passed since the last response, it will allow the operator to trigger again. And so the operator will say, yep, I'm not in cooldown anymore and should respond is equal to true. So I'm going to try to perform the action again on chain. Yeah, this would be for anybody that has liveness data showing in their trap. You would see on the front end dark green blocks. Those dark green blocks simply mean that the operator has identified that should respond is true. So if you have liveness dark green blocks, if you don't have liveness data set up, then it'll just be red. You don't need to worry about it. But it's a good way for you to see what is actually happening from the front end. What is your operator saying
And the
that it's
light
doing?
green blocks is just should respond equals false. So they're both fine. But on this trap, since it's the response contract is always active, it should responding true every time.
Yep.
So you'll only see
One of
light green.
the one of the questions from .cr is the trap dashboard shows dark green blocks when an operator reported with should respond is equal to true, but it doesn't show whether the response transaction was actually executed. It might be successful or might have failed in elapsed. No actual transaction result from the dashboard. Well, um, it's a good question. The best way you could know is kind of a couple different ways. You can go and see, like, find your operator address on Husky Etherscan, and you can see that if it performed a transaction on chain. Another good way to know that it triggered is if you see the actual logs in your operator that it performed a transaction. Um, and then obviously another good way to know is by running the cast call, right? So that cast call where it returns true, that's another good way for you to know that it actually triggered. Um, but it is a good point whether a response has actually been pushed on
Yeah.
chain and kind of visually show that from the dashboard. But for right now, those are the ways that you can see if something actually occurred. Um, Normally, in a use case like the chess game, for example, if you go to the chess head, if there's a move that needs to be validated on chain, you'll see a single dark green block, which is kind of indicating to the trap that, oh, I need to go validate a move. And then right after that, you'll see a light green block because should respond true got set back to false, meaning no pending moves to be validated. Um, that's kind of like a decent way to know at least that the trap logic is running, and you can see it switch between true and false. Um, for this example, it should only ever be set to true unless you have like some issues basically with your trap.
See, I
Yes, so it's a
see.
good question.
Can traps themselves be vulnerable? How do you minimize the attack surface of a trap? I think there's a couple angles you could look at that. The biggest angle is going to be um, the owner of the trap. You know, the trap is controlled by a key pair. And so, just like with anything, you need to um, be very secure with those keys and only keep them yourself or those in your company that are authorized to use it, etc. Um, Additionally, the trap code itself, we call them traps. It's almost like you laid a trap in the woods, like under a bush, so it's not seen until it's too late. But so if someone knows the trap code in advance, then it's much easier for them to try to work around it so it doesn't activate. Um, so keeping your trap codes, secret is a pretty strongly recommended practice. So, the trap code probably shouldn't be in a public GitHub repository, and so it should probably stay private. And then on top of that, if you deploy to, I think, just any seed node, you have some level of security with that. The trap code it's all compiled, so they're not able to like completely re-engineer one like perfect version of the original if they were to get the encoded um, trap bytecode. But then you could step it up another level and you could run your own seed node, you can run your own operators, so like all of it stays within your controlled infrastructure, and then you have the most control over everything in that sense. So a couple different ways you can look at it.
Uh, there's another question. What effect does triggering a trap have? Is it just an event? or does it trigger a penalty slash state change? Um, because you're triggering an on-chain action, that's the end result of a trap triggering, is some contract being called, some function on a smart contract on Ethereum getting called. The X function has like an event in it. So you could have, for example, in this contract for this workshop, we actually do have an event that gets triggered, um, and it's basically like emit event, and it has like some information in it. So when this gets triggered, when this respond to the Discord name gets triggered, this event will be triggered. So technically you could see for this event popping on, like some monitoring system see this event go off. But it can also change state, right? Because it's just a contract call. So it's kind of both. Change can occur if your response contract is doing that, right? So you can go and deploy any contract to Ethereum and specify it as your response contract and specify a specific function on that contract and kind of do anything that you want. So you could emit like 10 different events, right? You could emit a bunch of different events saying a bunch of different things, and then have that response function actually call. It's very composable. Uh, oh, where do you see Drosera in 5 years? What's the big vision? Well, it's a big question. Um, I would say that the big vision with Drosera and with traps is to make a tool that anybody can use for blockchain generally to be able to create really simple infrastructure that's verifiable, right? To be able to make infrastructure for any kind of automation, security, applications, being able to provide this tool and make it available to anybody so that people can kind of create more sophisticated whilst being able to have verifiability. So the big vision I would say is probably the biggest thing in that vision is probably dApp development. You can kind of already see that with the chess game that we've put together, and we have another dApp coming out soon as well. But I think that what we're going to see is people are going to make traps, and this would be really awesome because now, in the current paradigm of application development, especially on Ethereum, modern day applications, they always have smart contracts, but nowadays you always have to have an off-chain system. Like there's always some off-chain system that is happening on chain and then taking action. Um, and they do this in order to provide a lot more like functionality and some more sophisticated features. But the problem with modern day applications is that this off-chain piece is usually not verifiable. Um, and so it becomes a kind of centralized point of trust. And so with something like Drosera, people can actually get a verifiable piece for can not just audit the smart contracts, but they can also audit your off-chain infrastructure as well. And this is like super important because the off-chain piece is the piece that could be the most vulnerable. Clearly, there could be smart contract bugs, and that's why you have auditors. A lot of times, those auditors aren't looking at your off-chain infrastructure tracks. And what's cool with Drosera is that your off-chain infrastructure is a smart contract. So those same auditors that can look at your protocol and look at all the smart contracts you're using, smart contracts you've built, they can use their same expertise to look at your infra because it's written in Solidity. It's also smart contracts. Um, this should allow for people to kind of create a new kind of expertise in the space, know how off-chain systems can run with smart contracts, and they understand the Drosera system, and so there's kind of like a new ecosystem to be formed here, whether it's with like audit firms or security people or people who are making DeFi apps to say, hey, here's a new way to do off-chain compute in a verifiable fashion, more secure, more easy to test, and more easy to deploy. Okay, anything else that's good? The response function accepts several comma-separated parameters, and the response function accepts a struct containing several values. This might be a good one for you to cover, Jake, if you want to share the workshop example and look at that uh, should respond piece. If you want, we can go through the inputs to should respond and then the output and talk about the encoding.
Okay. Response function. I thought you were going to kick this one to John, but the response function accepts several comma separated.
I could also pull it up as well.
Okay, sure.
Yeah, yeah,
Maybe a little more on this advanced on the Solidity stuff.
I could pull up the workshops, no
that's a good
problem.
question. Okay.
Yeah, so let's look at the actual trap here. Um, so for should respond, you know, there's a couple of different things that are going on here, right? It's taking this input, which is just bytes, right? So this is in its array, it's an array of bytes. Um, the reason why it's bytes is because it actually makes it really easy for us to, this is kind of technical, in order to pass what is returned from collect into should respond. So you can see here, this data that is being grabbed in line 15 is being encoded into bytes, right? It's just this kind of struct of sorts of data of a boolean and a string, active and Discord name. It's being encoded into bytes. Those bytes are passed as an input into should respond, and those bytes are kind of decoded into, they're kind of broken back out into what their original types were. So we're grabbing right here for ABI.decode, we're decoding the first element of this array of this to its original form, which if you look up here, its original form was a boolean and a string. So we're decoding it back into a boolean and a string, and now we've kind of, we know what this data is. It's not just generic bytes anymore, it's specific data types. This is really important for traps to be generalizable, right? By having these functions be a little generic, by returning bytes and taking in bytes, it means that everything in between coded without us having to specify an interface of like for every single possible combination of data types, right? So it's really to help the interface, this iTrap interface right here, which specifies this exact definition, right? So it allows it for it to be generic, and it allows for us to decode this stuff so that anybody can use the iTrap template. Um, for the last part of should respond, this first piece right here that is being returned, this first element, it's always going to be either true or false. That is the thing that is determining whether should respond is considered true or false. True, false would be don't call the response function on chain. And then the second part of the return of should respond is actually the data that you would pass to your response contract. This is also encoded as bytes because, well, it can be any data type. Your response function can be any string, right? So this allows for us to also make this generic, right? We can say this function returns generically to create a standard for what a trap's definition is for these two functions. That would be the main reason why we kind of have this setup of encoding and decoding, and then why we have these, like, this first element is true and false, and the second is the data passed in to your should on function. That means that information that's calculated inside of that in this kind of off-chain domain can then be pushed on-chain. So this is kind of what some people have called asynchronous composability. It allows for us to kind of trap with any smart contract function, any smart contract, and create this pipeline for how do you collect and detect things, and then how do you say, this is what I detected, or this is the result I've calculated, and then how do you push it? Decoding and unwrapping of data. Um, this allows for us to, like, kind of connect all the puzzle pieces together, which is what you see here in this diagram. It's what allows us to specify really easily how do you connect an off-chain contract through an operator all the way on-chain. What is Trap.sol? I've missed everything. Well, Trap.sol is simply it's just your trap contract. That's all this is. This is the thing that's actually running uh, when your operator is opted into that trap and running it. It's running this logic. And it's running lots of collect data and ensure response. Yeah, Moe, that's correct. It's the contract for your trap. Okay. Curious to see how many people have actually ran this
So you've seen a couple more
example so
people come
far.
through.
Oh wow, yeah. I've already see quite a few people. Shout out to Xerox Smile, NutCR, Mr. Works, Goose, and Mike My Mind. You guys have already submitted and ran this workshop. Congrats and thank you guys. Um,
Yeah.
okay. I think that we could probably cut it here. Thank you guys for showing up. Jake, if you have anything else.
Yeah, thanks for participating in this mini series of workshops, everyone. I'm sure it won't be the last that we do, but keep in mind this is heading up towards TryTrapMe coming in the near future, which is going to be like this, but a little bit like this, but more personal for on your side and on steroids. So it's really going to take the writing traps to the next level. Um, we are going to get all the recordings of all of these workshops and get them posted to our YouTube channel here shortly, and we'll post about that on X for sure. Um, and yeah, thanks to everyone for being here and pushing your Discord names on chain. We appreciate it. I think
Okay,
we can close it out there.
perfect. Thank you guys.
All right, thanks. Have a great weekend, everyone.
Yep, GR, stay trapping, everybody.
See ya.